This is Ledin. I am from Aarhus University, Denmark. Yeah, sorry. I am today here to present our work, which was done during our master's thesis program, and it was regarding the proactive safety management in earthwork operation using IoT-based real-time analysis, risk analysis, and positioning system. So I am here to present, and they are my co-authors. And these are the contents, what are the general aspects of the safety in construction, and what are the precise research gaps and objectives, and what we made a hypothesis, and what was that, and the methodology, case study, and system implementation, and results, limitation, and so on. So we move forward with the general aspects of safety in construction. We know that we all know that construction industry is a very accident-prone industry, and normally we have so many accidents, but they are not statistically presented most of the time. But still, we can consider that around 24% of the entire EU region accidents are from the construction industry itself, because it's very congested. There are so many people around from different programs or different companies, from different ends actually. That's why there are so heavy consequences if there are a collision between the machines during work, either with machine to machine or machine to human beings. So most of the time it's fatal. I mean, death injuries happen almost all of the time, otherwise severe. So here we can see that what I have said, that the scenarios in the construction side. So what were the precise research gaps? We found out that normally there are a big lack of predictive and real-time analysis during our recent times, and we are overly reliant on the data, on historical data itself. And we don't have the sufficient behavior integration, that how people are going to behave during the work itself, construction work itself, or during the pathways, and how they're going to, there are always some from higher so sophisticated people to normal worker, so they have a different behavioral pattern. So we don't have that sufficient integration of that thing in an automated system. And we also have some data sharing issues, that many companies work in the same time. So there has always been some lacks in data sharing and decision making issues. So what was our research question? We raised a research question: can the IoT sensor integrated system can really identify and update the construction site risk in real time? And our core objective was making a simple and very easily accessible and understandable thing for the normal, and from a very sophisticated engineer to a normal manager or non-technical person can understand by watching it just by instance. And we made a hypothesis also that by consulting with so many people from academia and also from the industry itself, and we found out, we made a hypothesis that it is possible, and we looked forward to do that. And we actually approached to a DSR methodology. We first found out the problem, and then we made the motivation and so on, and we made the objectives, and then we made the design and developed it, and we had a practical implementation, demonstration and evaluation on the place. And later on we tried to have a expert validation, but it is still it was not done that much context. So what was the system requirement? Preliminary, we considered that the system should be automated. Like it is not likely we should put some data on it. It should be run by itself, and it should be able to make the situational awareness among everybody who has access to that one. And we have the projection. The system is able to project the next thing which is going to happen in the shortest time, and explain the situation, how the situation can be fatal or non-fatal, and how it's going to be. And then the visualization thing, it could be a visual thing that anybody can understand without any explanation. So we used this at the roadmap, how we used that one. And before doing so, we have to we actually considered install the IoT sensors in excavators, which has a 360-degree radius, and we calculated the dynamic extension of that one. Either it is somehow break anyway, then how much it can extend to how many extent it can extend. So we found out around 6.3 meter after it has a dynamic extension, and we considered around 2 meter of safety normally practiced offset for an equipment, and that's how we developed around 15 point something meter of diameter of for a safety radius of an excavator. Then we added another 12.5% of safety buffer. So that comes around 17.85 meter for one excavator. So you can see that if from any excavator to another excavator, the radius is more than 35.7, which is from center to center. If it is greater than the 35.7, then it is around, it is safe. And if it is less than 35.7, it is the circles are intersecting, then they are not safe. And also we made a per machine risk KPI and also a zone risk KPI, which we made around the unsafe time of a specific machine working in a specific area, and divided by the active time of during that area over that area actually. And same goes for the zone risk. And that's how we actually first made the system development in such a way that we first install the sensor itself, then through IoT core, AWS IoT core and Kinesis stream, we made a influx DB time series, and then we exported them in CSV actually. So then we made the JavaScript proceed. We load the CSD and calculate the distance and made the proximity check with some predefined, which we have rules which we have already. Okay, sorry. So this was the case study. It was in the Billund area, Legoland area. This was the scenario, like so. This was the video of the simulation actually. That was the per machine KPI you can see over there, and we have it is actually a long video, we may speed it up. And those were the static hazard we made. I forgot to introduce one thing for the static hazard, like accessways or electrical panels or storage yard or working yard, something like that. So you can see we made 3 options here, like live commentary. Each second, the system is updating its data commentary, where the machine is, how the severity is, and this way we can also see the machine KPI, how much risk it has associated with. So these are the results. We found out around 93% were machine to machine hazards, and around 7% were machine to static hazards. And so we made some tremendous things, found some tremendous results. Sometimes it was so critical that the violations were so minimal that without the distance, I mean the dimension of a cell phone, we have like 140 millimeter. It was a machine to static hazard distance. So within a small approach, it could have a fatal accident or something like that. So basically, we tried to find it through this way, and we also tried to answer what was the research gaps were. Through, I think you have got the idea that it is already it has been answered through the system itself. And then we also confess some limitations, that it also did not have that real world validation on that sense, because we did not have, it was a master's program thesis, so we did not have that much time to do that. And also the environmental factors were not also considered to the thing. And that's what I said, the traditional safety methods are normally reactive. We should be moving forward to a proactive safety system so that we can save more lives, and the normal workers do have their safety while working in constructions. Otherwise, we are moving so fast in the construction industry only due to productivity and something like that. We are only thinking of productivity, money, and these sort of things. But the normal safety of the workers and the people working around are greatly undermined. So it is a time to address these issues. Thank you all.